Today, what I'm going to try to do is give you a rigorous explanation of what the derivative is. Okay. And we're starting with this, where y is a function of x. Y is the dependent variable, x is the independent variable. And what this function, f of x, tells us is what the value of y is for any given value of x. That's what f of x tells you. Okay. And let's just begin with the definition of the derivative. dy dx is the derivative of y with respect to x. An alternative notation for the derivative is f prime of x. And it is equal to this. LIM stands for limit. And we'll talk about that in a little bit. LIM for limit of delta y over delta x as delta x goes to 0. Now, what is this delta y over delta x? Let's talk about this first. This is called the difference quotient. Delta y over delta x is called the difference quotient. And what it is the change in y per unit change in x over a certain interval as x changes. It's also referred to as the average rate of change of y with respect to x over a certain interval of x. Okay. This symbol delta means change in. So delta y is just this. y1 minus y0, the change in y. The value of y starts at y sub 0, and then it goes to y sub 1. So it's the change in y. In a similar fashion, delta x is the change in x. x1 minus x sub 0. Okay. Because y is a function of x, you can also write the following. y1 is just f of x1. Okay. When x takes this value x1, then y takes the value y1. Okay. And in the similar fashion, y0 is just f of x sub 0. Okay. One more point that you need to know is this. Instead of writing x1, we will write x sub 0 plus delta x. Because x1, the new value of x, is just the original value of x plus the change in x. Okay. Notice, if I just subtracted x sub 0 from both sides, you would see that that's true. X sub 1 minus x sub 0, of course, is the definition of delta x. It's going to turn out to be more convenient to write x1 as just x sub 0 plus delta x. This actually makes sense, because here's x sub 1 is the new value of x. It's just the original value of x plus the change in x. Okay. Okay. All right. Using all those definitions, we are going to write the difference quotient this way. We're going to write it as f evaluated at x sub 0 plus delta x. Recall that's just y1. minus y sub 0, which is just this, all over, we'll just leave this as delta x. The reason I'm writing it this way, the reason the book writes it this way, is we want to express the difference quotient as a function of x sub 0 and delta x. Okay. This expresses the difference quotient as a function of x sub 0 and delta x.